This is the Amp Hour Podcast. Released January 2nd, 2022. Seriously, already? Episode 571. Rube Goldbergs in space!
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
In 2022, is that correct?
We're in the future. We made it.
Am I actually correct?
We're not recording in 2022, but we are broadcasting this in 2022. So this future looks
bright,
pretty lame. No, pretty lame.
No, lame. Okay, right. Pessimist versus optimist. Okay.
Well, COVID's still here, so
just ignore COVID. It's done its thing.
Yeah.
Yep.
But the part shortage is still here.
No,
that part
that's
sucks.
It's still real. Well.
Yeah.
Yeah.
I don't know. I saw a news article that said TI is worth more than ever. It's like, yeah, thanks a lot, guys. We really care about your stock price when we can't buy a damn thing. Okay, cool.
I have to search for it now.
What's that?
TI share price. Texas. Oh no, I got something else. Texas Instruments.
You have to know the before to actually know if it's any different though.
Well, that's graphs are for.
I guess you can look at a chart, right? It's,
a year.
Well, yes, because
come on. No, that's a nothing burger. Okay, they've gone. Okay, in 5 years they've gone from $75 to $189. But I mean that's not that's just the regular. Every share's done that. Got it. Right. Yeah. So no, there's been nothing recent. In the last
no
year.
Pops, you're saying, huh?
No, there's no GameStop here. It went from the start of the year.
Here.
It went from 164 a year ago to 189 now. Yawn.
All right, well.
Come on. Yeah,
they're worth a lot, and they're not able to produce anything. You'd think if they're not able to get ships out because of shortages, they would be worth less. But no, that it doesn't really impact things. So.
But is there a silicon raw material shortage, or is it just they can't pump out the capacity required? I thought they were all running on all cylinders.
Well,
but they just can't pump out enough.
I guess that's a good point. Yeah.
Which means there's no component shortage at.
I'm just pissed about it, Dave. Okay, just let me be upset. Just let me be upset.
Right.
They should be worth nothing right now. Can't buy any chips. Pissed off about it. I just sourced a board the other day. It's just terrible. Terrible.
Well, just do what everyone else does. Blame Apple and Tesla for buying up all the shit.
Yeah. That works great, unless you have to actually get a board out. It's just trying out new parts and.
Okay. Yep.
Yeah. Scrambling. I just ordered a bunch of boards, and every part I bought for it, I bought from LCSC because I couldn't find what I needed in local distribution. Right. So going overseas.
So you just had to find the nearest equivalent. Is that the thing?
Nearest equivalent? Well, yeah, that was some of it, and it was so I couldn't find P-channel FETs that I needed with the specs I needed. So I was like, all right, well, going no name from China. Okay, fine, whatever. Probably low risk.
Yep.
Test it first. Yeah.
Yep.
So then I needed a buck regulator, right? I mean, those things are just I think the real thing I'm worried about here is designing something in. I can go on a DigiKey or Mauser right now, and I can go and find a buck regulator.
Yeah.
But if I don't buy enough now, then when I go to buy for the next board that is using the same stuff, I'm screwed. It's just there's nothing there. So I'm just trying to go, okay, whatever has the most in distribution at LCSC, I'm going to try that one. And it was a diode zinc part, pretty simple.
Yep.
I'm not doing anything fancy at all, but I just need to be able to buy parts, and it's stressing me out.
I can't remember who it was on Twitter, maybe Greg Darville or someone. Anyway, they were bragging how they found a part on, DigiKey or Mauser somewhere, and it had 200,000 in stock or something. And, they were bragging, hey, it's a good, what component shortage? And then I replied something along the lines of, well, try again tomorrow.
Yeah.
And he went, oh, yeah, I've been bitten before, putting in my order now,
Mm-hmm. Yep. Yeah. I mean, that's the thing.
Don't wait.
It could just happen at any point, and it's just there's no stability So you just gotta.
Even during normal times, I've had that happen. I've checked and I've gone, right, I'm going to, build a new batch of these, and so I'm just checking now, and they had, 5,000 parts in stock or whatever. Right, I'll order them all at the end of the week or at the end of the day, even when I've end of a couple of days later or I've got everything together and I've got it all in one shopping cart, et cetera, et cetera.
Yeah.
And no, they're gone like a day or two later. Yep. All of them. And it's like, damn.
So then I can give an example of why this is encouraging bad behavior as well. Because now I went and I bought, I didn't buy 10 like I needed. No, I bought 500.
You bought
why wouldn't I?
Yeah,
right?
Cool.
I mean, like I didn't buy all of them, but I bought 500. I bought enough to basically get me through a stretch of the next year or so. And maybe maybe everybody should always be doing this. I don't know. But, when you can't rely on distribution being there, it's like, okay, well, I got to, source my own parts cabinet now. And
usually I've done this based on cost. It's like, oh, okay, I'm going to buy a full reel because it's cheaper and that's what the manufacturer wants, right? It's not because, I need to make 100 of these, but I'm going to buy a reel of 5,000 because, that's just how it comes, right?
That's just how it goes.
Yep.
So, but I think that also makes the market more frothy then, because then people are buying out stock, and it's just like the same. It definitely encourages the same problem, and it's not like, I mean, I'm doing this, I'm freely admitting it, but I know other people are as well, and so then that just means that stuff kind of goes in and out of stock more often as well. And I think then if the systems that are behind this, right, so if the distributor rather is not prepared for that sort of thing, they're not like ordering bigger quantities for this choppy behavior, and it kind of just feeds back.
I'd love to know how they manipulate change their algorithms now, because this is like, because they would have algorithms that, once stock reaches a certain level, it'd be based on maybe previous, averaged buy or whatever. So they'd order X amount more. I'm sure there's not somebody, sitting there going, actually making this calculation. I'm sure it's an automated kind of thing where they make like an automated buy of new parts as soon as they run out, or 2 weeks before they run out. They can anticipate,
exactly.
How much
they
stock
just do like linear growth, and if someone pops outside
something
of
like that.
It's
but I wonder, it'd be interesting to talk to someone who actually does that sort of thing, and have they had to? I'm sure they would have to have changed their algorithms for this. Surely.
Yeah. I mean, I'm sure they see it up close and personal. So hopefully we'll talk to someone around that at some point. But
interesting. How many rolls of toilet paper have you got?
Just the normal amount. I'm not.
Just right. Okay. All right. Yeah.
Did that craziness hit Australia as well? I mean,
yeah, that's where it. That's where the first original viral video came from. It was here in Australia of these two women fighting over a roll of dunny paper.
But how recently though? That's
this was 2020. This was
it was around
last year.
Okay.
No, yeah.
Same. Got it. Okay.
Right. Yeah, that's where the craziness started here. The toilet roll, and that has spread. It spread within like a week. It was like, Walmart in the US, people were like, drawing guns at, 5 paces to see who gets the toilet roll in Texas. Yep. To see who gets the bog roll. Unbelievable. Unbelievable.
So here's another interesting thing about sourcing. So I had a discussion with someone about this earlier, and I've been doing this in my own space, but the idea of not necessarily like buying dev boards to rip chips off and stop your design. That's something people are also doing. But instead, designing in headers and kind of like making it more flexible to be able to pop in other designs and other types of boards, that sort of thing. So like I just designed a board with like a feather header, right?
That's one of the points I'm going to do on my video if I ever get off my ass and do it, about how to design for the component shortage. That is one of the things. Instead of buying a some sort of buck converter with a specific footprint, no, you put it on a daughter board and then it plugs in. So then you can you don't have to change your main board at huge cost and expense and everything else. You can just change the little buck converter board, right? So it's much easier.
That's kind of the modular design idea, but it's because of necessity instead of just for funsies.
Yep, that's right. So maybe I'll do that video eventually.
Yeah, that'd be good.
Probably a year too late.
Where you been, Dave?
I don't know.
I think it's I don't know. It's just a very frustrating time still, and
Yep.
Sucks, Dave.
Do you know what's not frustrating anymore?
No, what's not frustrating anymore?
Waiting for the James Webb Space Telescope to launch. It's only been, 20 years or something?
25, I think. Yeah. I think
Yeah, 25, is
90,
it? Yeah.
96 is when the planning started.
96, that's right.
Video.
Yeah, something like that. Yeah, it's insane. It finally launched on Christmas Day. I didn't think I'd ever see the day. And it's like, it originally started out as like an $800 million project, and it blew out to $10 billion. So,
I thought it was 12. I thought it got to 12.
Oh, it may have. I don't know. Yeah. Last estimate was 10, I think. I think people at this point are just, actually rounding down. It's rounding it. But imagine the pressure. Imagine the pressure of a $10 billion project on a launch.
I can't. Like, I cannot fathom, like, the amount of simulation that happened, like, all the things. You know, and it's going well so far, and there's still stuff, stressful stuff. There's that great tracking site. I'm sure you've clicked on that, like I have.
Oh, yeah.
Check in every day or so.
Yep. To see where
the
it's
NASA
at.
hosted. I just searched JWST status, and it's the Where's Webb.
Yep.
So where are we right now? Sunshield covers release. Ooh, exciting!
Oh yeah, that happened the other day. Yeah, that was.
The arm dropped, but now it's actually starting to unfurl the Sunshield. So
I don't understand how it can be 45% distance complete, yet we're only on day 5 of 30.
I think they got to slow it down.
Maybe that's a non-linear Excel. Yeah, they must really. They do have to slow it down a lot, because the problem here is they can't overshoot. If that is one of their things. If they overshoot the Lagrange point, they don't have the fuel to get back. Oh, so really? It's like, they can't get. Apparently,
I guess they cannot get it back. Huh?
No, it's like apparently they do not have the momentum to spin it around and go back. So they cannot overshoot this sucker. But it's just crazy. Yeah, but they show it as a linear distance on the graph. They show it as a linear distance.
Distance is linear. I mean,
yeah, but then
you mean for like to show the scale of it all, you would do log?
Yes. And and then it's like it is slowing down, because it was 0.98 kilometers per second a couple of days ago. Now it's 0.77. So it's already slowing down, but it's only on day 5 of 30. So if you can picture a linear axis of 30 segments, where we're only up to segment 5, right? 5.5, and yet we're 45% distance complete. So it's like, just bugs me. Anyway. Yep.
Yeah, I don't know, man.
It's a balmy 28 and 27 degrees Celsius out there.
On the hot side, yeah.
It's nice,
Yep.
Set up a lawn chair, and
I just finally finished the Expanse books. I don't know if I told you I was really excited about the Expanse. Book 9 came out.
No, okay.
That's no.
Right.
There's a TV series about it as well, and that's the book I've been waiting for patiently. It came out a couple weeks ago. Very excited about it. Just finished it. But one of the things they always talk about in there, it's like one of the hard. Yeah, it's mostly hard sci-fi, not like 100%. But one of the things they talk about though is like, when you'd see a spaceship slowing down, you would actually see its drive plume first. It's like, oh yeah, and it's like you never think about it. You always think about it like, like a thing slowing down. You'd see people in the cockpit. No, butt first, man. Butt first.
Yep.
What else should we say about the James Webb? I don't know.
This is why I was going to say, if you're traveling to Mars, if you want that wonderful Mars trip, it's like, don't bother, because you can't see anything. Like, you can't see Mars, you can't see Earth on the way. It's like, no, you can't see Jack. Yeah. It's just
pretty boring. Yeah, you just get video screens.
Yeah, that's it. So, the thing I find like just about this telescope is the number of things that have to happen, that have to work in sequence. And if any one of them fails, the mission is a wash, right? There's like over 200 things that have to happen. And some of those, including the deployment that just happened of the Sunshield thing, that had to have over 200, I think, little individual explosive charges in them. Well, they're not explosive charges. They're actually a resistor, which then burns and then
got it.
through like a string thing, and then there's a spring in there that launches these retaining bolts, right? But there's over 200 of them, so if one of them doesn't go off, that's it.
Yeah. I was wondering about this, like looking at well, how are they monitoring all this stuff too? Because it's like they're not going to add extra electronics that all these things go right. You think about it like, oh, well, you'd have a camera sometimes, you'd have other sensors or stuff like that. But just the amount
there'd
of
be sensor out the wazoo. Yeah, there'd be a sensor for everything.
Yeah, exactly. And but you still, it might just be a digital it just might be like a yes or no. And like things that hinge on this super criticality, like all you get is like, oh, look, it went to 1. Cool.
Cool. Exactly. Our 10 billion, we can't figure out where our $10 billion space telescope doesn't work. Right, exactly. Well, this thing's a 1. Okay.
Right, exactly. The bit packing is pretty extreme there.
Not much fidelity in your measurement.
That's right.
So, I just it's just insane. The amount of stuff. Sure, each one of those little catch release things had 2 separate drive paths in it, just in case one didn't work. Right.
Got it.
Oh my goodness. I've done that almost identical thing before, actually.
Yeah.
We had a sonobuoy which drops into the water from a helicopter or a plane, right? And once it lands in the water, saltwater battery activates, and then you have to trigger a gas bottle that then inflates the flotation bag, right? And that was actually held back with a physical resistor, like a 2-watt axial resistor, and then we wrap fishing line around the around the resistor, and then that holds back a spring, which then holds back a little pointy spike thing, which is right next to the gas canister, right?
Wow.
So it's all so it's holding it back, and you simply burn through the resistor. Like, you simply put a lot of current through the resistor, it heats up, it burns the fishing line, and then the spring releases, and then the canister goes. And they've got a similar thing here, but they've got over 200 of them, right? Yep. Which is just like, what?
No, I think that the assembly stuff too, that's where you have to imagine there's the most risk as well. Like, you can instrument stuff all day long, but if someone rolled it up wrong, or if there's just I don't know, there's just so many things that can go wrong in the assembly.
I was watching I can't remember who did the documentary, it was a YouTube video thing, going through like the history of it, and they said at one point they did a design review meeting, for want of a better word, can't remember the exact name for this particular meeting, but they found that there were over 100 single points of failure. So it's like, can't have that. Let's go back to, we can't have a single point of failure. And they had over 100 of them. So they had to actually redo almost everything,
Oh my God.
It was just, and they still ended up with a design with 200 catch releases for the bloody sun shield. I mean, let alone the other 200 steps they have to go through to get this thing to work.
Rube Goldberg machines in space.
And we talked about this when the first Curiosity was. Yeah. That was the first rover, right, on Mars to land with the sky crane thing, right?
I think so.
Well, I can remember talking about that at the time, and I go, at what point do you decide that, we're going to have these maneuvering we're going to have this hover system, and then we're going to drop this thing down on a crane, and then we're going to have this catch relay. Like, it's all it's probably like the most convoluted way to land, yet they decided.
Yeah, I thought that was because they needed the dust, I thought, as well.
It was the weight. Yeah. And also the weight of the thing, they couldn't they couldn't use the bouncy inflatable airbags like they've done before, and they had to and the dust and everything else. So they had to have this sky crane thing, this convoluted thing, but it's worked twice. It's worked flawlessly twice now, and they pulled it off. But it's like it just gives me the heebie-jeebies. Like, I've been in this before, like at a not this sort of scale, but
I mean, and there's so many people involved. Right.
Yeah,
it's
I know.
Just even just thinking about that, I just
freaks me out.
Not for me.
I know. It was
I'm not cut out for that kind of stuff. No. Obviously,
I'd be. Imagine being the engineer in the design review meeting, and you're arguing for this convoluted system. look, this will be better. Like, and you've got like you're screaming until you're blue in the face that trust me, this is going to work. And yeah, wow, it's just nuts. It's just absolutely nuts. $10 billion. So if there's anyone out there, surely there's someone in our audience who works on it.
Oh yeah, we'd love.
Surely
to
there's over 10,000 people who've worked on this. That'd be
10,000.
Wow. Yeah, 10,000. 10,000 people worked on this at some sort of level. So, yep.
Yes. Yeah, we'd love to. Please reach out. We'd love to, if you're allowed to talk about it.
Yep. Nuts. But anyway, yeah, I'm absolutely fascinated by this thing, and I can't help but watch every new step. So it's
every
the sun
new step
shield
is
at the
a
moment.
bit of extra stress,
Yeah, it's about another 4.5 days before the secondary mirror actually deploys, and then the primary mirror, and then the mirror segments. And then they've got the insertion. Hope they don't overrun it. Yeah, wouldn't that suck if everything worked?
I feel like the orbital mechanics stuff they've got figured out.
Right.
That was not what I was concerned about.
It's but you could always mix up in imperial and metric.
Yeah, it is interesting that they still give that as an option on the monitoring page.
I was going to say that they actually have it on the monitoring page. You would have think they would have learned. No, let's just have everything in metric. And
right.
And if you want to follow this thing, sorry, you've got to learn metric. Like.
Right.
Because
they could have like a dummy dumb button, and then instead of like switching it to imperial, it gives everything in terms of football fields. This is 400,000 football fields away from the L2 orbit.
And the speed is furlongs per fortnight,
exactly. Yeah, they should just add another button there.
Because like you would want, for something like this, you'd want to have like almost like a clean room mentality from like in all aspects of it, even related to the website. By that, I mean like there's simply no imperial units at all that even come into the building, like that. Yeah, like it's a complete clean room. That's an
interesting idea.
Yeah. It's like,
like digging through through like a technician's toolbox, be like, what is this? Inches? Get out of here. You're banned from the job site.
So there's no quarter-inch, wrenches and stuff like that to like bolts and things like that. It's just like if you let one in, it kind of like changes everyone's mind, subtly everyone's mindset, and then it seeps into,
That's right.
Like a virus, just seeps in. And
what is this torque nut size in fractional 64ths?
Oh boy, yeah. Holy crap! I just can't imagine. What a one-shot deal for $10 billion. Holy.
Yep.
Imagine if you were the one to screw it up.
I saw that recently. Oh, what was it? I was talking to my brother-in-law about and my wife about a legal case, family of lawyers, and they were talking about like there was like a missed deadline or something like that from a law firm, and it was like there was only one person in charge of it, but it was like a really, really, really big deadline, and they were completely liable for the entire case. The law firm was completely liable for the entire case because they missed that deadline. Right. And it was like it was just down to one person. It was like, oh my god. I mean, granted, that's only 40 million, but that's still a lot of dollar bills. So. Yeah.
I can't believe Ariane actually launched this. Imagine being the one to know your rocket failed, and it was like, because I think they're up for the cost. I think they are the ones who have to ensure actually.
Like they buy an insurance policy for $10 billion, you mean?
Yeah, I don't think it's up to NASA to do that. I think the insurance comes through the rocket company, although each individual for something this big, I'm sure they, it's all an individual negotiation or whatever. But if the rocket failed, like damn. But anyway, went off flawlessly. So good luck to the James Webb Space Telescope and its extra 199 steps left. So Yep.
Oh, we'll be watching. We'll be watching.
Damn. All right. What else we got to end the year out?
Well, speaking of units being mixed up, I was reminded of that a little bit when there was the how many ports we had to know tweet. Did you see that the other day?
No.
Let me send it to you here.
Oh, did somebody do a chart?
Yeah, like looking at how many port types were out there, and I was like, oh yeah, that's pretty classic. And just like the amount of things that were out there, and like, it's all getting kind of collapsed down to USB-C, and I couldn't be happier about it. Yeah, obviously there's a lot of downsides to that. You need a lot more compatibility layers and stuff like that, and a lot more software. But when you compare it to like this kind of thing, like I think about, telling my daughter what a let's see, one of the ones on here, that's something I used. Like the keyboard connector, right? Like a PS2, or mouse, or
oh, come on, they've
connector.
got AT keyboard on here. I mean,
I know. But if you look at all of computing history over time, right? It's pretty intense. Not like you would use all of these at once, but
this is only
there have been a lot of them.
No, of course, there's a lot more than this, because back in the old day, before you were born, Chris, every one of them was custom. Right, everyone had their own custom, especially card edge connectors. Card edge was the big thing back then. You'd have
When I was at ABB, I was working Bailey Controls. They had card edge that was completely custom on everything as well. And just like it was just the cheap way to. You only have to put one connector on one side, Like, cool.
And the good thing about card edge is that it's free. It's built onto your PCB. You're already paying for your PCB. You might as well put a card edge. Sure, you might have to pay a bit more for the gold, hard gold rolled. Because for those who don't know, when you're manufacturing a PCB, when you get a gold plated PCB, it is soft gold. It's not suitable for
that'll rub right off.
It's not suitable for a card edge connector. Sure, you'll get a couple of insertions. You might even get a few tens of insertions. But after that, right, no, you need what's called hard gold. And that's a separate process. And they have to mask off your board and do that as a separate, step.
Right.
So that's not something that you'll get on your typical, you won't get that on a prototype panel. They simply won't do it for you. You'll have to order your own panel, and it's done manually, and it's so you can't get your $5 board with hard gold edge plating on it, I'm sure. Yep. That just won't be a thing. But Firewire, I used to download all my videos from my tape, from my tape camcorder, from my tape camcorder, and all of them used to blow up. That was a big thing. Was it a TI chipset? Oh yeah, this was a big thing. If you maybe you can Google for it. Failed Firewire chips or something like that. Was it TI or somebody?
That plays right into the marketing, doesn't it?
There was some there was a tragedy of fire, the tragedy of Firewire or something. No, Firewire safety when plugging and unplugging. Yeah, they used to die all the time. And it was
just how they were. They didn't put the ground first or something like that.
Yeah, it was not hot pluggable protected or something like that. I can't remember the exact reason it failed, but if you hot plug the thing or just plugging it would you'd have like a 1 in 10 chance of it blowing up or something. It was a huge thing. And dead Firewire card. And if it happened in your camera, you were screwed, right? If it happened in your card on your computer, you can at least change the card. But
right. Well, back when computers had cards, I just got my laptop in, and there are no cards to be had in here. It's one and done. That's all you get. Circuit board with connectors.
Firewire, that was 400 megabits per second. That was like pretty sweet.
Yeah, I mean, at the time it was great.
No.
So
anyway.
Yeah, I don't know. I'm looking at all these things too, like, and all these connect, like we've talked about in the past, all these things get like repurposed, and how many standards, quote unquote, have there been on DB9 or DB25, or not standards really, but
I can remember DB15 serial ports.
Sure, why not? Yeah,
none of this 9 or 25 rubbish.
Yeah,
DB15 all the way there's actually quite a few DB15 fanboys out there.
Okay. Yep. I actually, so on this board I was just talking about putting out there, I was doing some flat flex connectors, so like FFC, if people see that, and there's just so many out there, so many you can do. Relatively cheap. But I was like looking around, I was like, well, how do you decide how many? It's almost one of those things where I would normally go to just like, what is the most common pin size? So when I did like the ABC board a couple years ago, I was just like, okay, well, the most common one is the 50 pin Hiroshi that I chose. It was like, 0.5 millimeter pitch or something like that.
Yep.
And it was just like, okay, just give me the most common one. That's all I really want. If there's extra pins, great. That's great. But like flat flex, it seems like, well, people need it to be really small and like customized. So there really are a lot out there. And I was just looking for like, I want to just know what is the most common so that I can.
Well, that's the problem with flat flex. It stems from the design decision to use flat flex in the first place, right?
Oh, interesting.
Yeah, like you've seen my teardowns of like, Sony cameras and stuff like that. And they're so complicated. Yeah. Like everything's
well, they
packed
need to
in
like
there,
just get
right?
signals over curved surfaces, like crazy stuff. Yeah.
And this is even back in the even the 70s and 80s, they were using flat flex for this very reason, is that when they had to design these consumer products, right? They're designed to meet some nice form factor, and you're forced into using flat flex, and then you're forced into using a certain size, and then you've got to, it's all, so it automatically becomes all custom, right? It's like, no, I'm just going to use the 0.1 inch pinch flat flex, here, the 40 pin 0.1. No, of course you're not, right? You're going to customize it for that particular need. Oh yeah, I only need to get 3 pins over there, so I'm going to use a 3-pin flat flex.
That's right.
Right?
Exactly. Yep.
Yeah, it's like, so that's why there's little, if any, standard in quote marks for flat flex.
Yeah.
Because it comes from the design decisions.
I really wanted was just like, there's a lot of displays that use 16 pins or something like that. That's all I really wanted. But I couldn't even find that. Maybe I just wasn't looking hard enough, but I had a hard time. Or like sorting by, well, this is a stupid idea these days, but like sorting by what's the most stock of. It's, in the old days, back in the before times, that used to be, a decent proxy, because there would be just so much stock of a thing that was very common.
Right.
I felt. But obviously that's not working now either. So I don't know. I just want all I want to do is just choose what everybody else is choosing, but then I also want to be able to buy all those parts if they're not choosing them at the same time.
All right.
Is that too much to ask? I just want to ride someone else's wave. That's what I'm really getting at.
All I want for Christmas is my 2 front components. My 2 front components.
Right.
Oh boy. My 2 in-stock components,
Yeah, no joke.
There's a t-shirt of that. All I want for Christmas is my in-stock components.
For next year. No, hopefully we don't need it next year.
Right, yeah, we're blowing out. Right. No, come on. No, okay, bets now. Are we still talking about component shortages same time next year? Yes or no?
We will be. Yes. Yes,
same
with an asterisk of it will not be as bad.
I'll be half as bad.
Sure.
I'll be yes, but half as bad. Yeah.
But we'll also be more used to it by then,
Yeah, right.
Be like, I designed this buck converter with 555, some bubble gum, and some duct tape, and
that's it.
An inductor I wound by myself, and capacitors are actually just glass jars filled with urine, and
everyone is suddenly discovering discrete transistors again.
That's right.
It's like, right. Yeah, a buck converter. Yeah, that's a bloody, that's just a few.
Yeah, what I do is I just sit there with a knife switch, and I just flip it back and forth really quickly.
Fast. Yeah, just really fast. Yeah. Oh boy.
Yeah.
Yeah. That reminds me, when I did a project using relays to drive stepper motors. I just drove the relays really fast in sequence.
Oh really?
Yeah.
How'd the stepper motor like that?
It worked fine. It will work fine. And yeah. So, anyway, it wasn't designed as a product. It was just a project, a one-off thing.
Yeah.
Yeah, and it worked. So yeah.
Killer.
And I programmed it in ladder logic, because this was an Allen Bradley PLC, right?
Oh, there you go. Yeah.
Yeah.
Yeah, that's your choice pretty much.
Yep. Yeah, exactly. Right. If you're into PLCs, it's Allen Bradley or bust, right? Is that it?
Yeah.
I'm sure you've worked on those, right?
I never have, actually. No.
I enjoyed ladder logic. I thought ladder logic was cool. When I was a teen, I thought, I just liked the sequential nature of it, and how you can put, port, like what are they? I can't remember the terminology names now. It's been so long. and that you just join things in like sequence, like series and parallel and stuff like that. So it's a combination of sequential programming using series and parallel components. I guess is a way to
it's like
describe,
writing out your relay diagram.
yeah, and it's just and so you can do really actually quite advanced stuff with it.
I mean, many factories run on ladder logic alone.
I'm sure the every single day you hop into a lift, that's probably ladder logic doing that, right? It's probably a programmable logic controller, ladder logic.
I was so confused about what you were saying there. I get it now. You're saying, so in the US, you'd say when you get on an elevator, I was thinking hop into a lift would also be technically correct if you're getting into a ride share that is pink carrier called Lyft.
LYF, right?
Yeah.
Oh, God,
a little confusing for me.
Right, sorry.
That's right.
The old terminology difference.
Now, here's the thing. If you were hopping into a Lyft LYFT and it was running ladder logic, I would be very impressed.
Really?
Oh, that car? Yeah, it runs on ladder logic. I'm not getting in it.
I saw this on the news the other day. I can't remember if it was here in Australia or it was overseas news and it was reported here. But it was on our local news. And this escalator, is that what they're called in the US? Escalator?
Yep.
Moving stairs, what
is that what you call it? Moving stairs?
No, we call it escalator.
An uppy-goey?
What?
I don't know. I was just trying to make up a funny Aussie term.
Right,
uppy-goey.
Uppy-goey.
Uppy-goey. Careful when you get on the uppy-goey.
That reminds me, we went to New Zealand and we were driving around New Zealand. Total non sequitur, but it just popped into my head. And they were advertising this local shopping center in this town. And they were like glowing about this local shopping center. Yes, was on the radio, right? There's a radio ad. And they're, advertising this local shopping center that's just open or something. And they went, it's got 2 levels, up and down. And we just pissed ourselves for the next hour, and we still talk about it to this day. We still use the joke with each other that it's got 2 levels, up and down, I just it just stuck in our heads, and it's
that's great.
I was so proud of this shopping center that had 2 levels and it had an escalator, Anyway,
hey, whatever's different, that's good. Yeah, exactly.
Anyway, I was watching the news, and it had, which is rare, and they showed this escalator that was going out of control backwards. And all these people were just piling up at the bottom, and bodies just flying over each other. And I went, "Oh no! How does that happen?" I thought these things were so, robust with the interlock. Right. Fail safe. I thought they're so simplistic in their control that it simply can't go wrong. Although I guess that's why lifts have the auto brakes on them.
Yeah, the mechanical interlock.
The mechanical clamps. So if the thing does suddenly plummet, these little clampy blocks, due to gravity, it's like a seatbelt. It's like how a seatbelt works.
Yeah,
it tensions up only when you lurch forward at a certain rate of speed. So these auto interlocks, so they don't require power, they don't require control logic, they don't require anything. It's just simply mechanical.
I wonder if elevators are the most seen, the guts or the control or the outside of it of any other I don't think about I guess HVAC systems as well. I'm just thinking about action movies. The amount of times I've seen the outside of an elevator because of an action movie,
right.
That doesn't happen normally. I don't really see the inside of an escalator because there's nothing exciting you can do in the movies with the inside of an escalator.
Right. Yeah, exactly.
But you got to be on top of or on the side of an elevator in order to really have a good action movie.
Right, of course.
Especially holiday movies like Die Hard,
Die Hard, yeah, exactly. Oh, boy. Yeah. Can't believe the same shit happened to the same guy twice. What are the odds? Oh, boy. Yep. Anyway. Very cool. Yeah, I just thought wow, how does that fail? If anyone's got any details on that, I'm sure you might have seen it because, it's a video, so it went viral, I'm sure, Yeah. It's, this escalator just going out of control.
I always think about that when, people talk about we want to replace this PLC with, an Arduino or, some higher level programming type thing. And I've designed some pretty serious bugs into my code in the past.
Right.
And one thing that's nice about ladder logic is it's
Yeah.
pretty easy to troubleshoot, and it's just
Yeah.
by nature it's simple, right?
It's
It
simple.
becomes a very heavy lift if you're going to try and make something super, super complex.
But then again, at the end of the day, that ladder logic is just a high-level programming on a processor, which is running its own whatever it is, right?
Sure,
So it's not, it's not like you compile the ladder logic into C code. I don't think it works. Maybe there is a ladder logic to C code like compiler or something, but yeah, like
I just mean that like that's
that's generally not how it works in the industrial programmable logic controllers. They actually run their own underlying operating system or whatever it is, I believe. I don't know if anyone's an expert.
That's right.
On
I mean, so like I used to work at ABB, and we had basically we had these control modules, and people would then go and write software that would then you compile down, and it would basically work on this controller that was inside a cabinet somewhere, and it was basically it could run ladder logic, it could run it could also run other types of programming languages, but it all got translated to this module. So
right.
Yes, that is correct. I'm just saying that so there's two things here. One is just the simplicity. There is more simplicity in ladder logic, I think. And so in theory, there's less chance for, kind of hidden weirdness, hidden bugs. That is not universally true, of course. The other thing I think about though is then just your user base shrinks as well, especially in these different expert areas, right? So like you have someone who's been doing ladder logic for 30 years, because that's totally possible at this point, and they're designing in systems for factories and whatever. There's a lot of people that do that sort of thing, and just switching over, and it's like, okay, well now you have to write in C++ or even Arduino, wiring type of thing. It's like, well, no, you just cut out a whole bunch of the workforce now. It's like, it's interesting how that kind of stuff, even if you wanted to, you couldn't switch away for certain things like that, because the talent isn't there for, not the talent, the experience isn't there, basically. So just how that stuff kind of continues on.
Does anyone do ladder logic? Does anyone in our audience still do it on a daily basis? Guaranteed?
Well, maybe
guaranteed? No?
Yeah, I think guaranteed.
Right.
And that's also really hard to prove the negative for, because we can just say they didn't write in.
Right.
Well, ladder logic people, they're notoriously shy. So.
That reminds me of a project I did way back. It was a finite state machine controller project, and I wrote my own finite state machine compiler software, right? So it would turn if then else statements, which is what a finite state machine basically is. It would convert that into EEPROM logic, and then you would simply have a counter that sequences through the EEPROM. So it'd burn all the words into the EEPROM, and then a finite state machine simply, it's a crude microcontroller, right? It's basically a microcontroller without a general purpose processor. You actually program in the if then else statements or whatever, and then it puts that into sequential bits in memory, which then you use a counter, and then you can have feedback as well that then controls, so the output can control some of the input, and it's cool.
That's cool.
So
yeah, that's great.
Yeah. Oh, actually, I have the schematic.
Okay.
Oh, hang on. No. Yep. There it is.
Deep cuts here.
There it is.
Cuts.
There's the schematic. And there was there was compiler software to go along with it, and we'll generate an EEPROM image. So what I'm looking at now is a 27C256 EEPROM, right, which holds all the logic, so to speak, right? And then I've got a HC574 latch, and then a 245 output buffer, and then the latch. So the input to the latch comes from the data lines on the output data lines of the EEPROM, and then they also feed back to the address lines. And then you've got inputs which go to the other address lines, so that you can so it can do, some pretty cool stuff. And then it just sequences through memory at a fixed rate, and then you have this fixed, so that's the processor clock is your rate, is your fixed rate there. And then it just actually clocks through all of this logic. And then it just goes through and it repeats the cycle again, just like a microcontroller would. And so
That's
it's
really
a very
cool.
crude microcontroller without a processor.
Was this for cost savings? What was the design
Oh,
requirement?
no, this was just for funsies. Yeah,
Oh, cool.
funsies. And I got this published. I got this
Cool.
published.
Yeah, that's great.
Yeah, somewhere.
Have you recreated this on the blog somewhere? You should do that. It'd be fun.
It's on my blog page. Yeah.
No, I mean, like, sorry, on the video. You should do it.
Oh, no. It's maybe I mentioned it in a video somewhere.
Yeah,
years
cool.
back. Maybe I haven't done a dedicated video on it because it's like it's one of those things which is from like the 70s before processors and microcontrollers.
What you should really do is you should try and trick Ben Eater into doing this.
No, right? Okay, yeah, of course. Yeah, I can drag out my old compiler software code and see if it still runs.
Yeah.
It was probably
there you go.
I can't remember if it was Turbo Pascal or whether or not it was Quick Basic. So if it's Turbo Pascal, that's a pain in the ass, but. Yeah. Anyway, that was cool. Yeah, that was
great.
how to,
great.
that was once again how to do stuff. Like it's guaranteed to work. There's no underlying operating system that can go wrong. So unless you get hit by a cosmic ray or something and your EEPROM flips, unless you get some sort of hardware failure,
So you're saying that you wouldn't want to program this to go on the James Webb Space Telescope, even though it would be radiation safe?
No, I totally would. I'd totally use this.
You would use this, but you'd feel safe that it would definitely operate perfectly, flawlessly.
Yep. Better than some bloody Arduino or Raspberry Pi crap.
Well, I didn't say that was going to happen. But,
no, if I just needed to do a few sequential stuff, I would hard code it into a chip. I would I'd hard code that sucker. Yep.
Cool. That's great.
Is there any other way you could use programmable logic controllers, right? You could use PLDs, but they don't really have the memory. Well, some of them they don't really have the memory architecture to do this. You could do finite state control in an FPGA.
Yeah, I think that would be a common kind of thing.
Yeah, you could probably do it. You could probably do it in an advanced CPLD, maybe. I don't know. But
I mean, I think most days you just wouldn't do this, right? But
no. You're like, there's no, but
if you're in space, you just do like triple redundancy and checking and voting and all that other stuff that happens out in space.
And all that other goodness. Yep. Exactly.
Yeah.
But
way above my pay grade.
But if something just has to work and it has to be simple, why, put something complex in there? Just do it old school.
So I think there are some reasons these days. I think one thing I think about is just like so maintainability is a very big one.
Oh, of course.
This would be a barrier to maintain, right? This is a very cool solution, but like thinking about like the fact that like so when you go and change something, you then have to run it through this other program, and it's just like tougher to maintain. Maybe write tests against it. You probably could do that sort of thing, but I think just a lot of the like a lot of the CI/CD stuff that I see coming out is just like
CIDC.
CI/CD, continuous integration, continuous deployment. That's like a lot of the software methodology kind of sneaking its way into hardware. The more I see it, Dave, the more I love it. So I think there's a lot of good stuff there, because what happens is you then every time you make a change, it just kind of checks everything, and it like basically you're just writing tests for everything. It's very
of course.
Yeah, so you could probably do that same kind of thing here, right? Where you push a change, it runs through your program. Do it
for anything. Yeah,
but then there would be much more like kind of like hardware verification, I think, as well in this scenario. So,
Well, I worked at Altium, and once they released a new version, actually hit a new version of software, which was every day, by the way. They were making a new version every day, and then they'd leave it run in testing overnight. They'd have everything was automated, right? Yeah. So, and then it would spit out the final version and go, yep, thumbs up, and then you'd use it and you'd find, 1,000 bloody bugs in the thing. Right? It's like
it compiles, but it doesn't do what you want it to.
Yeah, but it was supposed to be this comprehensive be all end all. Like if it passed these comprehensive overnight tests, then it was good to go. And it was like, nah.
Yeah, that sounds like that was more about the build system though than it was about the actual like UI, and like they started to hook stuff in even where you can like. You can have systems that test UIs after the fact, right? Where
right.
You write tests, so it's always doing the same thing. It's always putting stuff in the same place. That sort of thing.
But they had all these automated tests, which was supposed to check every aspect of the software, and it still
sounds like it was
1,000 bugs still got through. It's like,
Well, I mean, just saying,
All right. Anyway.
That's just one way that it's been done. But in the CAD realm, I guess we haven't mentioned this yet. There is some good news. Version 6 has officially been released for KiCad. So
Woot.
congrats to the team. It's exciting stuff. I gotta make some videos. I haven't made videos in a while.
Right. We'll have to link to the proper website, right? Not the dodgy malware website.
That's right. Yeah, not the dodgy one. Yep.
Right. I still can't remember which is which. Like, yeah.
The good one is KiCad.org or KiCad.org. The other one is not good. So.
Yep. The other one has a dash in it, doesn't it, or something?
That's right. Yep.
Right. Got it.
Yeah. So if people have been doing nightlies, nothing's really different there.
What a thing I would like to know is what's broken. What has changed? Like, can I still load my KiCad 4 files into it?
You will have to migrate the files. It's like one directional.
Of course. Yep. All right.
But then it should migrate fine. I mean.
Right. All right.
Yeah. I get to do it for myself. I still have nightlies installed on mine as like a secondary thing, and I'm still on 5. So, just got to make that. I think it's just like one of those things where you make the jump and then you're on to the next thing. So now that it's out, I feel much better about it.
So what major takeaways are there? Like, is there anything that goes, oh yeah, wow, I'm going to jump to version 6?
The big ones are, so like one of the hassles is there's a format change on the schematic side of things. Actually, there's a thread about this as well, about like what has changed there and stuff like that. I should pull that
What
up.
do you mean by format change, as in file format?
Yeah, like the file format for schematic stuff has changed. And so that's, pretty big when that happens.
Yeah, but apart from people migrating projects, how does that matter?
Well, so it was two-sided. One is that it makes it completely irreversible, right? So there's no chance of going back.
Of course. Yep.
But then the good side is that it's treated more like each schematic symbol is now an atomic unit, whereas before it was like a library, so it was like kind of all smushed into one file. And so for management, it's gotten a little bit better in that way, I think.
Okay, right.
Yeah. So here's a thread.
Is there an option to do it the old way?
No, because it's actually like a file format thing.
Right.
So like the footprints had already done that in version 5, where each footprint is kind of a standalone like actual file. So the .KiCad_mod. It is completely descriptive of that one footprint. Whereas now in version 5, the library, the .lib, it described, okay, well, you've got your LM317, it's got these pins, that and have these different functions, and then LM324 is right below that, maybe, and LM358 is right below that, so it's all kind of in one file. So if you wanted to separate stuff out, it'd become a lot more difficult from a file perspective. And so now each one would be its own schematic symbol as well.
Right. Okay.
Yeah.
So that's unlike Altium, who would introduce a new way to do something but not remove the old way. So then you'd have multiple ways. So you end up with like 3 or 4 different ways to actually accomplish the same task, because they didn't want to break backward compatibility, because that's
Yeah, this is a breaking change in that way, but there's a migration path. It's like, so
okay.
Other big stuff, the DRC rule stuff is much improved. It's much closer to like an Altium style thing. It's very detailed, it's scriptable, all that sort of thing.
Okay.
They've opened up the API a little bit more. And so there's another thing on our KiKit is another plugin. So the plugin systems basically have access to the API, and it's not as advanced as they want it to be, but it enables more plugins like this. So this is like a panelization plugin. So that's pretty cool. And,
right. Nice. Yeah. Okay.
So
I'll have to try it out. I have to come up with a project.
Honestly, I have it for a couple things. I haven't dug into it that much because it's not. I had other stuff going on, so I'll be digging into this too.
You were too busy getting work done to faff around with the tool, is what you're saying.
I mean, that's how it goes, right? I mean, like some people are like, I think they just kind of dive in. They're like, I'll just deal with the bugs. It's worth it for the leading edge features. I'm not like that, and I'm really glad that people do that, because that helps to find bugs when they're out there.
Yeah, of course.
Yep. So just have to pick a weekend and probably switch all my designs over.
Right.
Yeah.
Okay. Cool. Yeah. Well, I will have a play around with that in 2022.
There you go. Well, it's only like 12 hours away from you, right?
Yeah, right. Well,
18.
Yep.
Yeah. Yep.
Nice.
last thing we probably have time to talk about is this interesting. So the CH330, as I think the part that the first time I'd seen this company, which I've already forgotten their name. What is their name?
You told me at the start of the show.
Yeah, there's a PDF in here somewhere, but it's just like 3 letters, WFH or something like that. WCH microcontrollers. So it's a company out of China that does various silicon support parts and stuff like that. I had first seen them with, I think, the CH330, which is a USB to serial. And my first experience was, it was like I saw it on like a low cost dev board I was using, and you had to like download this kind of shady looking USB driver on your Windows machine
right.
from like China. I was like, I don't want to do this. Eventually I, read enough posts and I was like, felt okay enough about it. And I was like, all right, fine, whatever. And, I could then talk USB to serial to this very, very low cost chip. Great. And since then I've seen some other parts that have come out, and there's been some, you kind of see them floating around. There's not like a ton of information about them. Yep. But what's interesting is they just announced rather, a RISC-V BLE microcontroller with Bluetooth 5.3 on it. And if the other chips are an indication, this is going to be a very, very low cost chip. And so they're using RISC-V. And I think this is just what we're going to see more and more of, where, these low cost providers are just going right into RISC-V and just using the cores that are available out there. And they're like, yeah, we'll just make whatever. And this is where I think a lot of the RISC-V stuff's going to continue to pop up. And obviously it's happening at the high end as well. A lot of chip companies are using it, but very exciting to see this kind of thing. So super.
What's a 10-year prediction on ARM versus RISC-V? Because one's free, one's not. Because that's how ARM make their money, is to license their core.
First off, we should point out RISC-V is not necessarily free, right? So people
it's not?
So remember, RISC-V is an open ISA. It's the architecture and the instruction set architecture, right? So what that means is anyone can go and develop a processor for it.
Right.
But a lot of people who do that then charge licensing for that core. And it's not underneath any large umbrella. Like RISC-V doesn't do the...
Okay, so you're allowed to use RISC-V to create a core and then license that core yourself.
That's right. Yes.
Right.
And that's what a lot of people do. And there are then also free cores that are out there. Yeah. So like, you could go and grab a free core, or, you could go and design your own processor, or you could go and license one that's probably going to be less. There might be more competition in the market for...
Okay. I thought RISC-V was a core, but you're saying it's not. It's just a set of instructions or whatever. Right. Yep. Okay. Right.
We've said this a couple times on the show, but it's hard to remember. I mean, like I forget it all the time too. I'm like, open source processor, right. And it's not.
I just thought there was an open source core. Are there open source cores out there that you can just take and drop in?
There are also open source,
right? I thought there were
free to use cores, free as in beer. Yeah. So that's where it gets confusing, because that's the difference, right?
Okay.
So Claire Wolf, who we've had on the show before, did the Pico. I forgot the name of it. Pico RX, I think. There's a core that she designed that basically is out there, and I think anyone can just go and download that off GitHub and use it. It's a smaller core, but that's different than someone who might want to go and design like a large scale server style RISC-V processor, right? And it really can span from very, very small all the way up to very, very large heavy lift processing type stuff.
Right.
I think there's been more stuff kind of middle down, small to medium size processors, like equivalents of Cortex M0, equivalents of Cortex M4, but there are also some bigger ones at the high end as well, because RISC-V there's also RISC-V compliant processors that are running Linux, right? And they're in things like PolarFire SoC, FPGA thing, right? That's from Microchip. Right. And so like these things are everywhere. And in various sizes and flavors. But what's interesting is then we're also seeing them kind of at the what I assume is going to be a very low cost, maybe not low end, but low cost processor. And it's got a bunch of intriguing things on here too. So
will dominate in the high end, and RISC-V will dominate in the low end microcontroller space then? Is that the thing? Because ARM is being used in, like, the new Apple M1 chip. Well, no, they've got their own one, right? But ARM is being used in like high-end server processors and stuff like that.
Sure.
Right.
Sure. I don't think you could. I think that they are still not dominating in that space, though, right? Because that's the realm of the Intels and the Nvidias of the world. I guess Nvidia is trying to buy ARM, but and AMD.
Yeah, but they are a major player up there, though.
Sure. Yeah. I think. Yeah. They're not dominant though. Like I don't think it'll be. It's not a duopoly in that way, right?
Yeah.
So x86.
But will ARM sort of die out in the smaller microcontroller space in the next 10 years?
That is interesting.
Because
I bet they'll lose ground. I think.
I think that's natural, because the nature of the low end microcontroller business, right? Price talks, and if you have to pay a license fee to ARM for that thing, then that's a cost per chip, which you don't have if you.
Yeah, I think there's.
That's why Microchip didn't go down the ARM route, is because of the cost per core. So
on which
they
one?
got a much better
On
deal.
that Polar Fire thing?
No, with the other one, which is what PIC32s are based on. The it's not popping in my head now.
No, it's not MIPS.
MIPS. Yes, MIPS.
No. PIC32 is ARM based.
No, MIPS.
Okay, now I'm gonna look it up.
Or they changed. Did they? I don't know.
I could be wrong.
It was MIPS.
Okay.
It is MIPS.
I thought their old stuff was MIPS.
No? Oh, well, I don't know. Maybe they have new ones. But,
I guess. No, RISC. RISC. Yeah, you're right.
It is based on the MIPS.
M4K. Yeah, okay. All right. Yep. All right, fine. I wouldn't have jumped to them as the first thing, but yeah, you're right. Okay. It is still RISC, but that's basically meaningless at this point. Most things are RISC. Yeah, so I think that big chip companies will be the determinant in this way. But I think that to use like a TI, for example, right? They like bought Luminary Micro, and then they discontinued that, and then they got into the ARM space as well, and everybody's really excited about ARM. I think what it comes down to is kind of what they're presented with. So when I think of a TI, they want someone to show up with like, hey, we've tested this core, we're going to support it. You give us a bunch of money, we're going to give you a bunch of IP you can just go and throw into your chips. And so I think if a RISC-V company, a company that designed a RISC-V processor, shows up and says, here's all our testing, here's our cost structure that's less than ARM, here's our support plan, that sort of thing, I think then yes, they will. Right. I think at the beginning what we're going to see is like this inching along, people dipping a toe in the water type of thing. Of course. I think that's how it's going to start. But then I think when it does go, like when a big company comes
a mainstream player comes in,
exactly,
and boom,
I think there's a big support business around it as well, because like we talked about, it's not just open source and whatever, right? Like I don't think that TI is going to go and go onto someone's GitHub page and say, "Oh, look, a free core. I should put this into my into my chip." That's just not going to happen.
No.
So
exactly.
I think it's going to be more around an IP licensing company with a more favorable cost structure, like you mentioned. They will come in and they'll get a trial period, and then they're just going to start to inch their way in to product catalogs, and then maybe on the other side as well, consumers may be asking for it as well, right? Because it's a simple switch on the command line or whatever. Because then also, it's got to be supported. You think about like just overall ecosystem stuff too. Kyle and IAR and like other large scale IDE and software providers, they also need to support this stuff, and it needs to all line up. And so if it's not lining up, then people aren't going to be asking for it on the consumer side, consumer in this case being an engineer. But if someone is like, hey, I'm running GCC and it's easy for me to switch to a RISC-V based architecture with a command line switch, then it's like, that's no problem. I don't think that things are really going that direction as much as we might like, but assuming the software providers do give these options, I think people will start to ask for it as well. Also, if it's cheaper.
Yep. All right. Well, we'll see what happens by the end of the 2020s.
Yeah. By 2032, we'll be able to figure that out.
Right. Wonderful.
Yeah. My friend just got a passport updated and said it expires in 2032 or 2036 or something like that. It's just like, holy crap. That's like
Oh,
way beyond Back to the Future too.
Lewis Rossman, friend of the show, former guest.
Mm-hmm. Yep.
Lewis Rossman just released a video. I can't remember if it's on his live channel or not, but he just, no, I think it was main channel, where he talked about somebody, I'll try and link it in, but he said that they, their right to repair thing, they go, right, it was some state, Hawaii, I think it was, Hawaii.
Ah, yes.
Their state, they actually said, oh yeah, we're going to make manufacturers, give people all everything they want, right? The schematics, the parts, and everything else.
Hawaii is known for its manufacturing.
But it doesn't come into effect until 2050.
Oh wow,
they actually put that in the document, and that is piss
kicking
take.
the can as far down the road as you can get it. Yeah,
that is a piss take of biblical proportions. That is just
that's on the level of carbon emissions and other things that really don't mean anything when the politicians are saying, that is
a hilarious video, and Lewis just laughing at that, ranting about it. It's great. Anyway, do we have time for a last part of the week?
Sure.
We have a part of the week. Here we go. It's the Vishay Furnace? Cernus? SFERNICE.
Worth it just for Dave to try and pronounce it. Yeah.
It's got to be a silent F, right? Cernus. I guess.
Furnace.
Vishay bought Furnace.
I think it's Furnace. Yeah.
This is with a silent S? Okay, right. I guess they bought them out, right? So it's, anyway.
This is like the part you were talking about on the
yes, yeah. Well, we were talking to so we could have segued to this before, but I obviously didn't think of that. Anyway, just the name of it's cool. Massive Electro-Pyrotechnic Initiator Chip Resistor.
Yeah.
Or MEPIC for short. MEPIC. Massive
a little boom device inside your
a little boom device.
Did you think that you wanted to blow up parts the old-fashioned way by just overloading a resistor? Well, Vishay wants you to do this on purpose.
This is a surface mount. It's basically a resistor. It's a controlled resistor that heats up in a controlled manner. So it's a surface mount jobby. It's an 0805. It only comes in one size. And it basically looks like any other surface mount resistor, except it looks like a current shunt kind of thing. Like you've got the big end caps, and then there's just the one trace going along the middle, right?
Yeah. It also works as a fuse.
It works as a fuse, right? It's designed to go into, fireworks. You embed these things into fireworks or some other, if you're doing explosive charges in mines or something, I guess, or something like that. I don't know.
You see, the way this works, folks, is you put current through it, and then it gets as hot as a furnace.
as hot as the blazes of hell and damnation itself. Name the movie.
Yeah.
No,
Back to the Future 3.
Thank you very much. All right, I would have been disappointed if you didn't get that.
Yeah, come on.
I'm talking as hard as the hell. Anyway. So you embed this into, presumably onto a little board, and then you shove all the,
I figured this is like the kind of thing that you used in like a scuttling type of thing as well, like when it needed to scuttle like a
we simply
thingy.
But we simply taped an axial resistor to the side of the flotation bag, and then we just burn the resistor. Okay. It burns a hole in the bag, and then it sinks to the bottom of the ocean.
Got it.
Yep.
So like a boring explosion.
Right. Yes. Yeah, so you embed it, you presumably you put it in a little pocket, and then you fill the little pocket up. You fill this on top of this with your, I don't know what chemical explodes. I don't know what powder stuff that explodes.
Saltpeter.
I don't know, your fireworks, your sulfur material or something.
Really stinky farts.
Yeah, and it's just cool. It's just a controlled current shunt, basically, that just heats up and
I couldn't tell if there's anything like inside of this thing that actually would
no there's nothing inside. I think it's just what they deposit on top of the trace that gives it the controlled effect. It's just very, very predictable, very reproducible, so you can be guaranteed that it's going to ignite your stuff after X seconds, of passing X current through. So yeah, it's very cool. There's no like curves for it. I'm sure you could probably get like, design curves for it, but there's nothing in the actual data sheet. I think this is just a short-term data sheet, maybe. Oh no, because these things are made to order. Down. That's right. You've got to. I think you can buy it on Mouser, but I don't know if they have like a generic one. But basically, it's basically designed to order. You order what specs you want, what performance you want, and they make it for you, kind of thing. So yeah, it's very cool. I like it.
So the data sheet says the heating zone will be impregnated by the user with a primary pyrotechnic material, usually wet primer, followed by drying in such a way that intimate contact for an optimum heat transfer of thermal. So basically, you dry like a explosive charge on top of it, like a some kind of chemical jobby. I don't know.
Yeah, but, maybe there's some sort of liquid you could put in there that helps. I don't know. I'm sure all the explosive experts, fireworks.
Well, from all the time watching the elevators with action movies, I know that C4 is another
right.
thing
C4 is the go-to. So, right. Yeah, of course.
Right.
And it's always got C4 written on it,
That's right. Yeah. And it looks surprisingly like very cheap white clay that you might get at a a model shop inside a movie studio.
Yeah, exactly. It's I believe it's like the whole idea is that it's ordered to your specs. Like you can buy something on Mouser, but I'm not sure if you actually just get a generic one or something. But the whole idea of this is it's tailored to your specs. You give them the specs you want. And how it works, and they will manufacture them, to you. So I believe like there's just some sort of coding on the top which gives it the controlled thing, the controlled behavior. So it's cool. I just think it's with some. So thank you to whoever pointed that out on Twitter. I think it was. It's just some like industry specific thing that you didn't know existed. Like it's basically a resistor that heats up and.
Pretty boring in that way, but works great.
But yeah. And I guess you aren't actually, there isn't much to waste. You're just wasting this little 0805 surface mount resistor. So it's not like, a huge wastage thing that, this thing's going to blow up every time your fireworks goes off. But, like a fireworks show, it'd have thousands of these things, right?
I think the downside to this sort of thing is you don't get like the again with the movies, the fuse with like the little trail of fire going towards
with the trail of flame coming out. Yeah, they need to have a little,
Right. Like what else is Wile E. Coyote gonna see? He can't see the electrons going into the
that's
resistor,
right.
So
yeah, there you go. So there you go. That's part of the week, and that's the amp hour for this year. We're done.
This is the new year, so I think we've sufficiently started off the new year on a low note.
Wah, 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 wah. Yep.
Sorry, folks. More of this in 2022.
Hey, same drivel every week.
You get what you pay for.
Yeah, exactly.
See you next one. Good.
Catch you next time.